Okay, in this video series, we're going to go ahead and start looking at the trigonometric basics that we need to go ahead and basically proceed through trigonometry, introducing the unit circle, and a bunch of other things. We got trigonometric graphing and some other good stuff that lies in wait for us. So let's go ahead and take a look at our topics. First of all, we're going to define and look at a radian, okay? We're going to find out what linear and angular speed are all about. What is arc length and sector area, and how do I calculate them? Unit circle, and a review of right triangle trig, and adding some new stuff along with it. Okay, so the vocabulary that we're going to need to get started is going to be a few things that we're going to knock out. First of all is that we need to know arc length. And arc length is this distance right here on a circle. So say, for example, if you're eating a pizza, you don't like the crust, and that distance right there is going to be the arc length, the length of the crust that you leave on your plate or whatever, okay? Central angle, and the central angle is going to be this guy right here, and that is going to be made up of two radii, all right? And so this radius here and this radius here, and it creates an angle just like a wristwatch would, or a wall clock or whatnot, if it had two hands that tell time, of course. And that central angle is going to be important as we use it through the entire section here. So a couple different names for variables are all down here. We got alpha, beta, theta, omega, and phi. Okay, and all of those could be used, just at sometimes as a variable for an unknown angle, okay? And then finally, we got this business of some review of supplementary angles. We know that they're going to add to 180 degrees, and complementary angles are going to add to 90 degrees, okay? So, some new stuff mixed in with some old stuff, but let's take a look at the skills that we're going to need to knock things out in the first part here. So, okay. So one of the things that I want to do is that we're going to be adding a lot of things that look like this, all right? Some fractions. And a quick way to go ahead and do this out, and we can do this a couple different ways, is that you think of fractions as, you got to write them, pardon me, up vertically and whatnot, and then subtract them out. But I'm going to show you a quick way to do these out, okay? And say if I'm subtracting pi divided by 3 minus pi divided by 4 there, what I can do is that I can multiply these guys, which is going to give me 4 pi, bring down the minus sign, okay, and then multiply these guys, which is going to give me 3 pi, and then bring down the division bar, and then I go 3 times 4, which is 12. And that is going to give me, at the end of the day, 4 pi's minus 3 pi's is going to give me 1 pi over 12, okay? So you kind of think of pi as a variable, if you will, or 4 objects minus 3 objects is going to give you that object, just like pi would, okay? So the next example, just to show you a different way, is that we could also get common denominators, just like we would with regular fractions. So, for example, if I had pi over 6 plus pi over 12, and I wanted common denominators, I know that a common denominator of 6 and 12 would be 12, so I could go ahead and multiply 2 to the top and the bottom of that guy, and I could go 2 pi plus, or divided by 12, plus 1 pi divided by 12 is going to give me 2 pi's plus 1 pi is 3 pi's divided by 12. And then anytime that there are some numbers like 3 over 12, I can reduce that down. So 3 goes in the 3 once, so I'd get just pi, and 3 goes in the 12 4 times, and so that would just be pi over 4. Okay. One of the things that you need to be able to do is find radians and degrees on your calculator, and depending on what calculator that you have, you might need to Google it or ask in class how to go back and forth between radians and degrees. All calculator, the TI-30 that we recommended for class and the graphing calculator has that capability, so you want to make sure that you're able to tap into that. Okay, and then finally, something that that comes up in trigonometry all the time is that we need to rationalize denominators, and we know that square roots in the denominators are bad, and so the way that we said that we want to undo them is that we want to multiply the top and the bottom by that square root, and so on the top we go 3 square root of 2, and then square root of something times if it's a square root of the exact same number is just going to give us that number, and that is rationalized. And likewise, if I have the square root of 3 on bottom and I multiply the top and the bottom by the square root of 3, I get the square root of 3, 1 times the square root of 3, which is square root of 3, and then square root of 3 times the square root of 3, which is a 3. Okay, so that's the stuff that we need to get started, and so let's jump into that next video and get our hands dirty with perhaps some newer stuff. Okay, in this video, we're just looking at a different way to think about angles here, okay? And if you can imagine a wristwatch or a clock, just like with some rotating hands, what we're looking at is the way that we're going to agree that angles are measured when they are on this, when they're on a Cartesian graph or the X and Y axis type graph, okay? That's going to give us a circle, and we're going to explore that as time goes on. So the first thing that we need to know is that our initial side right here, angles, it starts there, and then it's going to go, if it goes counterclockwise, or if it's turning to the left, that means it's going to make a positive turn, and then it is going to end on a terminal side. So whatever angle is measured right here starts on this side, and then it cranks its way on over to this side, okay? So that would be an angle in a standard position. You have an initial side where you start, which is oftentimes, almost all times, going to be on the positive x-axis, okay? This right here, and then it is going to spin around the circle just like a clock hand would and create an angle. A positive, like if you have a positive angle, it's going to go in this direction, okay? And if you have a negative angle, it would go in this direction, okay? So for example, if I were to say this is going to be a positive 120 degrees, right? I would start here, and then it would go in this direction. But if I had a negative, right, maybe, one second. This angle right here might be a negative 30 degrees. It would go in this direction. So that's kind of new for us in regards to it could go in a positive or negative direction. We haven't had negative angles before, so that is that's kind of a new concept, and we're going to explore that in the future here. Coterminal angles are going to be angles that share the same terminal sides. So you notice that with these angles right here, okay, they both start alpha and beta, the A, which it looks like a little, I don't know, fish, and a B looks like a fancy bee there, is that alpha is going to go in this positive direction here, and beta, if it goes in this negative direction here, it both shares that terminal side where it stops, and so those would be called coterminal angles. And likewise, if I had alpha, which is just going to go a little bit in the positive direction there for that guy, and I had beta that was going to turn all the way around, pass it up, and then stop again, kind of like a spinner in a game that you would play, then they would both end up on the same terminal side, and there'd be coterminal angles. Okay? So, let's take a look at sketching these and visualizing angles down below, and then we're also going to try an exercise that's going to help us visualize this stuff out. So let's take a look. Okay, so when we're visualizing these angles out, one thing that I want to go ahead and to start with is that we imagine that this is going to be 0, and then this would be 90 degrees. This is going to make sense in a minute. 180 degrees. And down here is going to be 270 degrees, and then back at 360. So what we're doing is that with 225 degrees, we start here. And we know it's going to be positive, so it's going to be going in this direction, okay? So we also know that it has to be in between 180 and 270 degrees, okay? So our angle, we're going to go ahead and it's going to stop right about, let's see, right in the middle here, okay? Because 225 is going to be in the middle of 180 and 270. So we would label this as 225 degrees, okay? Now, a coterminal angle would be, we know that there's 360 degrees in a circle. So therefore, if I started right here and I went in this direction, what angle, if I went in the negative direction, is going to go ahead and meet with that? So if I think to myself, all right, I have 360 degrees, and I've already eaten up 225 of that, what is going to be left, okay? And so it looks like the answer is going to be 135 degrees. So if I go 135 degrees in this direction, which will make it negative, a negative 135 degrees, then both angles are going to meet in that particular place, okay? Let's take a look at this next one here. Start here, and like I said, 0, 90, 180, 270, and 360 degrees in a circle. So if I'm going negative 90, that means is that my first turn is going to go in this direction. And if I'm going 90 degrees, that means is that I'm going like a right angle right here. So that is going to be that angle right there. That's a negative 90 degrees. Now, if I wanted a coterminal angle with that, I can imagine that if I went around in this direction and met up with that angle, that would give me a positive 270 degrees. Okay? So again, that's how that guy is going to work out. Okay? Okay, for 405, that's going to look like it's going to go around the circle more than once, okay? Because we have 360 degrees in a circle, all right? And so this means is that this angle has started here, and now it has gone 360 in the positive direction, because it's positive, and then some. So to find out how much further than 360 it's gone, I can say, all right, well, if I take 360 off of that, it looks like I'm going to get a, let's see, a 45 degree angle. So it looks like it's going to go further, so it's not going to stop, right at the 360. It's going to keep going past that and go right to 45 degrees, and it is going to create this guy right here, okay? So that, all the way around, it loops around, and that is going to be a 405 degree angle. Now, what's another angle that's coterminal? Well, we could just say that just going from here to here, which we know is going to be 45 degrees, because that's what's left out of 360, is going to give us the coterminal angle of 45 degrees. Okay. And then finally, a negative 270. So let me set up the angles here. Okay, so for this guy, it's going in the negative direction here. So we start here, and what we're going to do is that we're going to turn in this direction, 180. So that's already 180, and what I want to do is go about 30 degrees more, and that's going to give me my negative 210. Okay, which, oops, that looks like 20. Fix that up. So it's a negative 210. So I know that if I go in this direction, okay, what's going to be left if I have 360 and 210 is already eaten up from it, and that answer is going to be 150 degrees is going to be a coterminal angle. Okay, so we got kind of a lot of stuff to think about as far as what direction things, well, first of all, where to start, right? Positive and negative angles, which negative angles could be pretty new to us, and then how to go ahead and visualize angles that are going in each different direction to make coterminal angles. So all pretty important stuff, and we're going to explore some more important things in this next video coming on up. So I'll see you there. Okay, in this video here, we're going to introduce radians, and this seems like a really difficult concept, but it's not too bad once we start to break this thing down. And radians is going to be a different way to go ahead and say degrees, okay? And we're going to have to get good at both of these because this is where higher end mathematics goes. And as we progress, radians oftentimes is a unit that is referred back to. So here we go. It says, what is a radian? A radian is the measure of a central angle that intercepts the arc S, okay, equal in length to the radius of the circle, okay? And so this basically means, let's not get too, wrapped up in all that. It's very, very wordy there. Is that anytime, say if you have a pizza again, and you slice that pizza, okay? So that pizza slice, which is R, okay, the radius of your pizza, is going to be equal in length if you take the crust of that pizza, okay, and you stretch it straight out, okay? So if you stretch that straight out like this, and when those two are equal to one another, that is 1 radian, okay? So it is when the arc length, the crust of the pizza, is equal to the radius, okay, of the actual pizza from the center to the crust. Seems a little bit difficult, okay? But we're going to break this down the best that we can in the next videos and lessons right here, so we're getting good at it. So radians is measured as an arc length, okay? So the crust of a pizza or pie divided by the length of the radius, okay? So this brings us to how many radians are there in one full circle, okay? So we take the definition of a radian, which is, again, length of the arc, the crust, divided by the radius. And we know in an entire circle, just like if you had a pizza, it is going to be the circumference. So if you just took the crust of your pizza off, that circumference would be, as we learned from other classes, 2 pi r, okay? That'd be the length of that. So we know that the arc length, we're looking for one full turnaround of the circle. How many radians are there in one circle? So the arc length is the same as the circumference. And so what we do is that we take the circumference formula and we put it in right there. And then we turn the radius into r, and then the r's cancel out. And so there are going to be 2 pi radians in one whole circle, okay? So again, 2 pi radians are going to equal to 360 degrees. Okay, so what we're going to do is that we're going to look in the next video here how to transfer back and forth. That is that just like change units from radians to degrees and then practice them later. So I'll see you in the next video. Okay, since we introduced radians, let's go ahead and take a look at how to convert to degrees, the radians, degrees, and back and forth. And the formula that I've always memorized is this. And let me explain how that works. Say if you have some angle, and I'm just going to say some angle right here, theta. So we're looking at proportions here. Is that angle in regards to 360 degrees, okay, which is the number of degrees in a circle, is going to be the same ratio in radians as 2 pi is to 1 turn around the entire circle, as we learned in the last video, okay? So anytime that we want, if we have degrees, we can plug in the degree measure and then solve for radians. Or we can go backwards. If we have radians and we want to solve for degrees, we plug radians in and then solve for degrees, just by doing some the cross multiplying and whatnot. So let's do an example real quick. 135 degrees. So I know that that is going to be a degree measure, and so I want to put it right here. So I'm going to say 135 degrees is to 360 degrees, as theta r, which is theta in radians, is to 2 pi. So after I go ahead and do some of the crisscrossing here, well, basically what I'm going to do is that I'm going to solve this thing out. And we're going to solve this out by doing some crisscrossing. But I want to, on the left-hand side, I want to reduce that fraction, which reduces down to 3/8. So I get 3/8 equals theta r 2 pi. So what I want to do now is I want to cross multiply. Okay, so I get 3 times 2 pi, which is going to give me 6 pi, and 8 times theta r, which is going to give me 8 theta r. Okay, and then I want to know what theta r is. That is at radians, so I divide each side by 8. Okay, those go out, and I end up with 6 pi over 8, which is going to be the same as 3 pi over 4 radians, okay? And so, that said, is that 135 degrees equals 3 pi over 4 radians, okay? So just to go ahead and show you, about 135 degrees is going to be right here, and 3/4 of the way to pi is going to go ahead and be the same radial degrees, okay? Or say radial measure. All right, so let's look at the next one and see how a negative sign could go ahead and impact it. Okay, so for the negative 60, I plug in up top because that's the degrees, and I want to know how many radians that is going to be. So that said is that I'm going to reduce the left-hand side. And from here, that reduces down to, pardon me, 1/6. And I am going to cross multiply. So I end up with a negative 2 pi, negative 1 times 2 pi. And then 6 theta r is going to go ahead and equal that right-hand side. I divide by 6 on each side. Those go out. And I got a negative 2 over 6, that's going to give me a negative 1 pi over 3 radians, okay? And we don't need the negative 1 there. I just put that there to show the cancellation, so it's actually going to be a negative pi over 3 radians, okay? So that's how you do that guy. Okay, for this next one, we want to get 15 degrees, okay? And 15 degrees is going to go ahead and be on top right here. And we want to get radians, so I'm going to reduce the left-hand side. All right, which will look like that. I divided 15 in the top and the bottom to simplify this fraction right here to get this guy. And then cross multiply. So I get 2 pi equals 24 theta r. Divide each side by 24, and that's going to give me 2 pi over 24 equals theta r. And then this is going to cancel. 2 goes in the 2 once, 2 goes in the 24 12 times. So theta r is going to equal pi over 12. Okay, so that is going from degrees to radians. So let's take a look at going from radians to degrees. In this case, I have 4 pi over 3, and I want to know how many degrees that is. So I'm going to plug that in to theta r and solve for theta d. So this is the way that I set this thing up. Okay, now on the right-hand side is going to be a little bit tricky if we have a fraction. So let's look at the setup up here, okay, and how to simplify that out to make this problem easier. And so if I have 4 pi over 3 divided by 2 pi, that's the same as 4 pi over 3 multiplied by the reciprocal of that, okay? And we can visualize this out as the pi's going out, right? And 2 goes into doing a cross cancellation. 2 goes in 2 once. 2 goes in the 4 twice. And so I end up with 2/3 on the right-hand side. And so I can rewrite this as theta d over 360 equals 2/3. Now, I do some of this stuff, which is going to cross multiply. So I end up with 3 theta d equals 2 times 360, which is 720. And then divide each side by 3 to get theta d is going to equal 240 degrees. Okay? So basically what you're doing is the exact opposite of what we were doing over here, is that we're given a radian measure and we're trying to go to degrees. Okay, so let's find out what the next ones are real quick. Okay, for a negative 3 pi, I'm going to go ahead and plug this in, and it looks like the pi's are going to cancel out. Okay, so I'm going to get theta d over 360 equals a negative 3 over 2. Let's do some cross multiplying, and I get 2 theta d equals, and I'm going to get a negative 3 times of 360, which is going to give me, it's going to give me a negative 1080. And then I'm going to divide each side by a 2. Okay. And that degree measure is going to go ahead and be a negative 540 degrees. Okay. And so, yeah, let's go ahead and take a look at the last one for good measure, and then we'll have plenty of examples to try this on our own. Okay, so we have theta d over 360 equals 5 pi over 8 divided by 2 pi. So let's go ahead and knock this part out up here. That's like 5 pi over 8 divided by 2 pi, which is 5 pi over 8 multiplied by the reciprocal, because that's how we do the compound fractions. These are going to cancel out, and so multiplying straight across, we have on the right hand side 5 over 16. And so when we rewrite this, we're going to get theta d over 360 equals 5/16. Let's cross multiply and see what happens. Okay, so 360 divided or multiplied by 5 is going to give us 1800 equals 16 theta d. And now we have to divide off 16 on each side. And at the end of the day, I believe that's going to give us theta d equals, or the amount of degrees that 5 pi over 8 equals is going to be 112.5 degrees. Okay, so this is a standard way how we go back and forth to converting from degrees to radians and radians degrees. Okay, so let's go ahead and get this mastered with some practice, and then I will see you in the next video to push this concept further. Okay, so in this video, we're going to go ahead and take a look at a way that we can just have to memorize a certain amount of information from this very exhaustive trigonometric chart that we made here, and use reference angles and all of the quadrants positive values that we learned in the previous video to go ahead and evaluate trigonometric ratios. Okay, so let's go ahead and take a look at the part that we are going to grab from the exhaustive list of functions on the side here. Okay, so using this method, we can go ahead and just basically memorize this part that's in that yellow rectangle there, and put it over here. So, and use small sketches of the unit circle to go ahead and start to put these pieces together. So let me go ahead and fill in the rectangle to the left here. Okay, so here is this chart here, and what we're going to do is that we're going to do the first example, and I'm going to fill them in as we go, and I'm going to do as many examples, let's do 8 of them so we can see how this works. All right, so here we go. And notice that I have removed the chart because we don't want to lean on that thing the entire time that we're doing these. We want to use this method because, again, this method is going to help us streamline what we've learned, okay? So if I look at the sine of 120 degrees, we know that our reference angle is going to go ahead and, our angle is going to look like this. So here's our 120 degrees. Now, if that's 120, we know that our reference angle is going to be what's left over to make 180, so this is going to be 60 degrees. So we're going to have a 60-degree reference angle. So we rewrite this as the sine of 60 degrees. Now, to do the last part, okay, is that we're going to take a look at where the terminal side has, and that's this guy right here, has landed. Notice that it's landed in Sine's quadrant. So that means is that the result is going to be positive. Then I just need to look up top and find the sine of 60 degrees, which is going to go ahead and be root 3 over 2. So I know that that is going to be the square root of 3 over 2. Okay, let's take a look at another one. Okay, in this one we have the cosine of 135 degrees. So that means is that it is going to go ahead and be right here, and that guy is going to be the 135 degrees, and the reference angle that is going to complete the 180 is going to be 45. Okay, so we rewrite this as the cosine of 45 degrees, and we notice that the reference angle, or I should say the terminal side right here, has stopped in Sineville. Now, that basically means is that cosine is going to be negative there because only sine and its reciprocal are going to be positive. So therefore, that's going to give us a negative square root of 2 over 2 because the cosine in the reference angle is going to be the 45 degrees right here. So you can see that a reference angle is handy because it's always going to go ahead and put things back into this chart here, and we don't have to memorize that entire giant chart that was off to the side over here. Okay, let's do another one. Okay, so we got the tangent of 7 pi over 4. Now I realize that these radians are going to get a little bit tricky, and so, but if we look, we know that there's 2 pi radians in one entire turnaround here. And if I put this into a decimal right here, 7 pi over 4, then I'm going to get a number that's going to look like this. So that's going to be 1.75. So a way that we could look at it is that it's going to, and since there are 2 pi, there is 1.75 and there's 2 pi radians in one whole circle, so we could go 1, and then 0.75 is about 75% of the way there, and we're going to get that as a, pardon me, as a reference angle. I'm sorry, as the angle that the terminal side of the angle that we're measuring. Now, from this, the reference angle is going to go ahead and just be pi over 4. Because if you think about it, is that if I have 7 pi over 4, which is going to be the original angle, if I add pi over 4 to that, that's going to give me 8 pi over 4, which is going to just give me 2 pi. So that's going to complete this little angle part right here. So let's do some rewriting. First of all, the reference angle, and that goes right there. And so we rewrite as the tangent of pi over 4. Okay, and we look to go ahead and see that this is in cosineville. And so therefore, we know it's going to be negative because only cosine's positive, and the reciprocal, which is secant, is going to be positive in the fourth quadrant. And so therefore, it's going to be a negative. And I look at the reference angle for the tangent of pi over 4, that's going to give us 1. So the tangent of 7 pi over 4 is going to be a negative 1. Okay, in this video, we're going to take a look at, we're going to start off with, this is the unit circle, okay? And we're going to fill this in here and learn more about it. But what we have to do is that we have to be comfortable with labeling the parts of the unit circle, visualizing it in our head, and being able to, again, draw it out in some cases, so we can use it to solve problems, okay? So the first thing that we're going to go ahead and do is that we're going to, from the lessons past, we have this as an initial side. And we know that when we turn a side like this much right here, or a side like this much right here, this is going to be a positive turn of the angle, and this is going to be a negative turn. And we need to go ahead, and there are certain angles in the unit circle that are kind of like the greatest hits of the unit circle. That is that we use them over and over again. And we're going to learn how to label them correctly and methodically in this video. So the first thing that we're going to do is that we know that we would start at 0 degrees here, where this would be the initial side of some angle. And what I want to do is that I want to start off by counting off 90 degrees, and 90 degrees increments will look like this. Okay, so those are all the 90-degree increments, and cutting the unit circle into 4 parts. Okay, so if you cut it into 4 parts, then each one of these, from just geometries past there, is going to go ahead and be a right angle and give us 90 degrees. So going from 0 on over to 90 degrees, and then this on over to 180, adding 90 each side, going in the positive direction. This is going to give us 270, and this will go on over to 360, and then we start on over again. Okay, so that's one of the first ways that we could label our 4 checkpoints here, which is going from 0 to 360 degrees. So let's look at the next, which are going to be the 45-degree checkpoints. Okay, so each one of these right here are going to be increments of 45 degrees. Okay, and that's going to be, as we're going to learn later on, a very important angular measure as we move forward. So that said, let's label these out. I'm going to start here again with 0 degrees, and I'm going to travel all the way here to 45, adding 45 each side, 90, we already have that. Oops, going on in this direction, adding 45 is going to give us 135, and going on over here is 180, traveling around, adding 45 to 180 is going to give us 225, adding 45 again is going to give us 270, which we already have, 45 once more is 315, and adding 45 over here is 360. Okay, so now we have all the 45-degree increments labeled, and we're going to move on to the 60-degree increments. I'm sorry, the 30-degree increments. Okay, so here we go with increments of 30 degrees. So let's count around 30 degrees starting from this guy right here. So we go 0, 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, and 330. Okay, so it looks like we have all the angular measures already labeled out for this unit circle. And again, you notice that they are increments, and I'm going to remove the yellow lines here. Okay, so there we are. And notice that something that I want to keep in the back of our mind here is that our hint, hint, nudge, nudge is that if we look at the bottom of the paper that's not shown right now, is that we have some 30, 60, 90 triangles and some 45, 45, 90 triangles. And notice that all the increments of these particular angles are of those special right triangles. So we're going to be using those in conjunction with what we've just done here in a later video. So that's how you label all the degrees of the unit circle, and in the next video we're going to tackle labeling the radians, and so I'll see you in that next video. Okay, in this video we're tackling reading radians for this unit circle here, and so to do so we have that formula that goes and changes degrees to radians, but we don't want to go ahead and do that every single time. Let's come up with some counting patterns to make putting the radians on the unit circle a little bit easier. So let's start here. We know that 0 radians is, or 0 degrees is 0 radians. So these two are going to be the same. If it's 0, it's 0. And we also learned that in one turn around the entire circle, how many radians are in one turn around the circle, which is going to be 2 pi. So let's go ahead and use this information to go ahead and start to formulate the different parts that we're going to need to break down to label the radians correctly. Okay, so if there's 2 pi radians, okay, in one turn around the entire circle, then a half a turn must be 1 pi radian, okay? And so if halfway in between 0 and pi, there must be pi over 2 radians, okay? So that means pardon me, not half a radian, pi over 2 radians, okay? And so this is like 1/2, this is a whole, and so this is going to be 3 pi over 2 radians, which is going to go ahead and be like 1.5, and then we're back to 2 pi radians right here, okay? So it's easiest to go ahead and get those labeled first, and then we're going to take a look at a little bit of a counting trick to get all the different 45 degree and 30 degree increments. So here we go. Okay, so this is the way that I like to show students to knock this this thing out for the 45 and then the 30 degree increments. Is that, first of all, there is going to be a number, and then it's going to be in front of pi, and that the number that's going to be on bottom that we're going to for the denominator is going to be the number of slices that the 1/2 turn is going to be. So I know that sounds weird. This is 1 slice, 2 slices, 3 slices, 4 slices, and so therefore this number under here is going to be 4. And with that, then I can just go ahead and count around the circle, increasing that number sign by 1 each time, starting at 0 until I get all the way around the circle. So let's go ahead and see what that looks like. Okay, so the first is going to be, and we already have it as 0, but that would be like 0 pi over 4, which we know is going to reduce to 0, okay? Then this next one for 45 degrees, I'm going to bump that 0 up 1, because that number sign is always going to change, and it's going to be 1 pi over 4, or just pi over 4. This is going to be 2 pi over 4, but we know that 2 over 4 reduces down to 1/2, which gives us that. The next one is 3 pi over 4. 4 pi over 4, which the 4's cancel out, and we know that we're just going to get pi. 5 pi over 4. 6 pi over 4. 6 over 4 reduces down to 3 over 2. 7 pi over 4. And then 8 pi over 4, which 8 over 4 reduces down to 2, which you're going to go ahead and get this business of 2 pi. So that's what we're doing. We're counting this number right here is going to increase, starting at 0, increase by 1 each time, and this is the number of segments, or the number of slices in one turn around the circle. Okay, so we're going to do the same thing for the 30-degree angles. Okay, so for all the increments of 30 degrees, we're going to take a look at this guy right here, which is a number that's going to increase from 0 till we're done, all the way going around the unit circle. And the 6 on the bottom represents 1, 2, 3, 4, 5, 6. Okay? And so therefore, that is, again, we want to take a look at one half turn around the circle. How many slices are there? And that bottom is going to stay the same, and that number sign is going to go from 0 all the way around, reducing it as necessary. So let's take a look at how this is going to work out. Okay, so here we go. This is going to be like 0 pi over 6, which is 0. And a lot of these are duplicates. I'm just doing it for a quality of life thing, for instruction. This is going to be 1 pi over 6, which is pi over 6. This is going to be 2 pi over 6, which is going to reduce down to pi over 3. 2 over 6 reduces down to 1 over 3. 3 pi over 6, 3/6 is the same thing as 1/2. 4 pi over 6, which is 4/6 is going to reduce down to 2 pi over 3. 5 pi over 6, which is just going to stay as is. 6 pi over 6, where the 6's cancel out, and we just end up with pi. 7 pi over 6, can't reduce it down. 8 pi over 6, 8/6 reduces down to 4 pi over 3. This is going to be 9 pi over 6, which reduces down to that. Okay. 10 pi over 6, which is going to reduce down to 5 pi over 3. 11 pi, 11 pi over 6, which is going to stay as is. And then finally, this is going to be 12 pi over 6, which is going to, 6 goes in the 12 twice, which just gives us our 2 pi. So to clean everything up, this is what the final unit circle should look like. Okay, so there it is, all cleaned up, okay, and we have all the degrees labeled in different shades of blue, and then all the radians labeled in different shades of green, and we're going to be accountable for being able to label those and visualize those out to use the unit circle in a rewarding fashion. So our next video is going to tackle how to go ahead and fill in all these parentheses and use them to go ahead and evaluate trigonometric ratios. So I'll see you in that next video. Okay, in this video we're going to take a look at how to get all of these parentheses here filled in so we can use this unit circle to evaluate trigonometric functions, hopefully with ease. And so what I want to do is I want to take a look at this particular point right here, okay? And we know that this point corresponds to that guy on the unit circle. And so what we're going to do is that we're going to take a look at how to get those values based on the fact that, again, that this is 30 degrees or pi over 6. And when I say that, this particular point right here is going to be 30 degrees. Okay, and how are we going to get the x and y values for that based on that information? So here we go. Okay, so with this 30 degrees here, this should look pretty familiar because we have ourselves a special right triangle. And the unit circle always is going to have a radius of 1, and so I've adjusted the sides, this side right here and this side right here, so it works out correctly for the particular special right triangle. So how is this helpful in getting this particular point? Well, what we can view is this, is that we got this, which is 0, 0. And in order to get an x value, that means is that I'm going to have to count out x units in this direction, right? In order to get a y value, I would count out that many units in that direction. And we can see that the x units are going to be the square root of 3 over 2, and the y units are going to be 1/2. So basically, we're using the sides of the triangle to dictate the points that we're going to use for the unit circle. So that's how we do the 30 degree. And moving on to the 45. Okay, so the 45 degree angle, the next stop right here, which is going to give us this point. And it looks like in order to get that point for x and y, we got to go x over, which is going to be the square root of 2 over 2, and y up to get the square root of 2 over 2 again. Okay, and so that is going to bring us on over to the another 30, 60, 90 triangle, which is going to be positioned differently. So let's take a look. Okay, so we got this 60 degree angle here, and like the previous examples, is that we're going over x, so that is going to be 1/2, and we're going up y, which is going to be the square root of 3 over 2. Okay, so we're going to stop here at the moment with this, which is going to be the first quadrant, and then I'm going to show you how to reflect these over the x and y axis to get the rest of the parentheses, and then we have some other stuff to talk about, as well as with the 0 and 90 degrees and 180 and 270. So we'll get there in a minute. Let's just go ahead and take a look at how to fill in some of these other points. Okay, so we're going to concentrate on these guys over here. And one thing that we have to remember is that anytime that we reflect over the y-axis, okay, that means is that the x values are going to turn negative because they're going from a positive, right, to a negative in the second quadrant. So therefore, all of these guys are going to be the same right here, the y values, and the x values are going to change to a negative. So let me go ahead and write those out. Okay, so you notice that all the x values now have turned negative, okay? And so therefore, what we want to do is that we want to reflect again over the x-axis. So go in, hold on, let me clean this up a little bit. Okay, so now that that's cleaned up, we're going to reflect now all of these particular points, okay, around the x-axis, okay, which is going to change things like the following. Notice that all the y values are going from a plus to a negative, okay? And over in the third quadrant, all the x's are going to stay negative because they're still on the negative side of the x-axis. And now all of these guys are going to turn negative as well. So it's going to look much like this. Okay, so notice that all the y values have turned negative. And what we're going to do now is that we're going to do another reflection in this direction. And let me clean this up a little bit and show you what that's going to look like. Okay, so that means is that all of these values are going to go ahead, and the x values are going to go from a negative to a positive, and the y values are going to stay negative. So we're reflecting once more on over in this direction, okay? And so that means is that all of these guys, the x values are going to turn positive and the y values are going to stay negative and look like this. All right, so there is the last of them. And one thing that I want you guys to notice is that soon as you get these values right here, okay, and all this, those are going to stay the same, and you just, if you reflect them and change the sides accordingly, you're going to end up with a better understanding of why these are what they are, okay? So what we're going to do is that in the next video, we're going to take a look at how to get these, the rest of these coordinates right here by defining out the x and y values as a function of sine and cosine. So I'll go ahead and I'll see you in that next video. Okay, in the last video we went ahead and we looked at how to get all of these coordinates on the unit circle by using special right triangles. In this video, which is going to be a real quick look at this, is that we're after the other coordinates that go ahead and they couldn't have a right triangle to go ahead and represent them because they're right on an axis. So therefore, what we're going to go ahead and do is we think about this, is that in a unit circle, the radius is 1. So if I go ahead and I extend this all the way on over here, okay, this is going to give me the coordinate. If this is 0, 0, then this is going to be 1, 0, okay, because this distance would be 1. Again, it can't make a triangle like this because it is going to not make a triangle with the x-axis, okay? So therefore, it is just going to be 1, 0. Likewise, if I were to look at this angle right here, okay, again, I couldn't make a triangle with this because it's on an axis, and since this is 1, it's going to be 0, 1 up here, okay? And moving around the circle, we're going to go to this part right here, and since we're going in the negative direction, this is going to be a negative 1, 0, and going in this direction down here, this is going to be 0, negative 1, okay? So now we have all the pieces put together, and we have all the greatest hits of the unit circle all filled in. In the next video, we're going to take a look at some things in general for the unit circle in regards to x and y and how it relates to sine and cosine values and how to start using that to make rewarding calculations. So I'll see you in that next video. Okay, in this video, we're going to take a look at these definitions right here and why they are what they are, and then we're going to start using them to evaluate trigonometric ratios in a quick and rewarding way. So let's go ahead and take a look. Is that if I were to start to label these sides of this kind of generic triangle here, it would look like this. Okay, so if we look at the way that this business of the triangle is going to go ahead and fit with an x value, okay, some x value, some y value, and the hypotenuse that is always going to be 1 because it is a unit circle, this is going to help us define these values that are down below in the left-hand corner. So let's go ahead and take a look at how these are going to play out. So first things first is that if I look at the sine of theta, which we know is opposite over hypotenuse, we would have y over 1. And so therefore, y over 1, which is this y, we know that the sine of some angle is just going to be the y value of the particular point that the radius intersects on the unit circle. And likewise, when we have the cosine, that is going to be x over 1, adjacent over hypotenuse. And so therefore, that's just going to be the x value of the point that intersects on the unit circle. And the same when we go through with the tangent, we got opposite y over x. And then the reciprocals that were just introduced a few videos ago. So we got hypotenuse over opposite, which is going to be the reciprocal of sine, which is going to give us 1 over y. We got cosine, which is going to be the reciprocal is secant, and that's going to be 1 over x. Okay, oh, these look the same here. I just want to make sure that you know that that is y. And then finally, this business of tangent, which is going to go ahead and be adjacent over opposite, which is going to go ahead and be x over y. Okay, so that's where these definitions in general, as it pertains to the unit circle, are going to go ahead and be defined out. So what we're going to do in the next video is to take a look at these definitions and how they relate to the unit circle and start to fill in some of these trigonometric charts so we can understand how to derive these out in a rewarding way. So I'll see you in the next video. All right, in this video, we're going to go ahead and take a look at how to go ahead and use what we've done in the previous videos with this unit circle right here and the definitions that we discovered to fill in this chart right here. Okay, so it's going to take a little bit of work, but after we put all the pieces together, hopefully we can see why this works so nicely. Okay, so the first thing that we want to do is that I want to fill out the radians column. And the radians column is going to be right here. So that means is that all the degrees that we have right here correspond to a particular radian. All right, and so I want to get those filled in right here so we can have the degrees matching the number of radians. So let's go ahead and do that. Okay, and again, the way that we got those is from our unit circle. 0 radians is 0 degrees, 30 degrees is pi over 6 radians, 120 degrees is 2 pi over 3 radians, etc., etc. So we're just filling this on in. So this next concept that we're going to take a look at is a reference angle. And a reference angle basically means is that, say if I go to 60 degrees right here, okay, the reference angle is always going to be the angle that you make with the closest x-axis. So in this case, it would be 60 degrees, okay? Now, it seems like, oh, well, of course you went 60 degrees. But say you went 210 degrees over here. Your reference angle would be 30 degrees because it is going to be the degree measure that you make with the closest x-axis. And we have to go ahead and also recognize that these right here, the axes, the y-axis and the x-axis, we can't make triangles with the x-axis with that because there's no way to make the triangle either way. And so those don't have a reference angle, okay? So that said is that I'm going to fill out the reference angles right down here. And we're not going to use them per se in this video, but they're going to be super important in the next videos when we start to put things together. So I wanted to introduce them here. So here's what they look like. Okay, so there's all the reference angles done out. And what we're going to do now is that we're going to start tackling the sine, cosine, and tangent, and then the reciprocals. So let's concentrate on sine right now. So here's the sine column, and sine's definition that we learned from the last video is that it's going to be y over 1. So if I were to take the sine of 0 degrees right here, it would just be 0 because it's going to be the y value of those points that we discovered. The sine of 30 degrees would be 1/2. The sine of 150 degrees would be 1/2. The sine of 240 degrees would be the negative square root of 3 over 2. So we can see why all of these values are going to be super important on the unit circle because it allows us to define sine, cosine, and whatnot as we go all the way around. Now we're just concentrating on sine, but anyhow, this is what it's going to look like. And you notice that as we go around the unit circle, okay, it's just going to be all of these y values, right, here, and going around in this fashion, etc., etc. So here's what they look like on the chart. Okay, so there they are. And we're going to go ahead and next work on cosine, which is just going to be the x values. So again, the cosine of 0 is going to give me 1. The cosine of 60 degrees is going to give me 1/2. The cosine of 300 degrees is going to give me 1/2. The cosine of 225 degrees is going to give me a negative root 2 over 2, etc. So no matter where I look on the unit circle, wherever that the terminal side stops, the x value that it points to is going to be the cosine of that. Okay, so this is what that's going to look like. Okay, so there is the cosine row, or I should say the cosine column, done all the way out. Okay, so next, and there's going to be a little bit of a sad face here because we got tangent, and tangent's going to require a little bit of work for us because it's y over x, so we have some division to do. But I'm going to show you some quality of life tricks to go ahead and get these pretty easy. So let's go ahead and set this up for tangent, at least going from 0 to 90, and then see where this goes. Okay, so here we have tangent going from 0 to 90, and what I want to do is just introduce how we're going to set this thing up. So we got to go ahead and by definition go y over x. Okay, so the y value is going to be basically y value is here, and we're going to have to put it over x. So we're going to get 0 over 1, which is a 0. And so that's not that difficult. However, when we compound fractions out for the tangent of 30 degrees, this is what that's going to look like. So the y value is going to be, for 30 degrees for tangent, going right here, okay, is going to be 1/2 divided by the square root of 3 over 2. And so when you're dividing fractions, you go ahead and you take the first fraction, and then you multiply the reciprocal of the denominator, okay, which is going to be this guy. Those are going to cancel out. And so we're going to get 1 over the square root of 3. However, we have to go ahead and multiply the top and the bottom by the square root of 3 to rationalize the denominator. And so we're going to get the square root of 3 over 3, okay? So I'm going to clean this up real quick so we can go on. The tangent of 45 degrees is going to be root 2 over 2 divided by root 2 over 2. And we know that anything divided by itself is going to give us 1. And for the tangent of 60 degrees, which is going to be, so this is the 45 degree guy that we just got done with. And then so the tangent of 60 degrees is going to be right here. And so we'll have the square root of 3 over 2 divided by 1/2. So we get the square root of 3 over 2 multiplied by the reciprocal, which is going to be 2 over 1. Those will cancel out, and we end up with the square root of 3. Okay. And then finally, for 90 degrees, we have something that first time that we're going to see with these trigonometric ratios is that we have 1 over 0, which is going to be right here. Okay. So that said, is that we got to remember that anything divided by 0 is not going to go ahead and be good news, and so we know that this is going to be undefined. So that said, is that these values that we just discovered right here, so pardon me, this, and this are going to go ahead and all be in some way, shape, or form the numbers, whether they be positive or negative, for the tangent column as we go around the unit circle and we keep doing the y divided by x. Okay, so we got to remember also when we're dividing with the tangent out is that a negative divided by a positive, or a positive divided by a negative, is going to give us a negative. And for these guys right here, a negative divided by a negative is going to be positive. So remember our sign rules as we go ahead and we march around the unit circle for tangent. So this is what the tangent column is going to look like. Okay, so there it is, all pretty much laid out. Okay, and so what we're going to do next is that I'm going to introduce how to deal with the reciprocal functions, okay? And so the reciprocal functions are going to be cosecant for sine, okay? So that means is that we take what it equals to, which is going to be y over 1, and change it to 1 over y. So basically we're just flip-flopping the value of sine. And so, and you notice that the same holds true for cosine and secant, as well as tangent and cotangent. So I'm going to show you how to tackle cosecant, and then you can apply the rest, the same technique to the rest of the particular reciprocal identities. So let's take a look at what sine equals straight across and how to deal with taking the reciprocal of it. Okay, so since we know that these are reciprocals of one another, that is sine and cosecant, what we're looking at then is taking these values, taking the reciprocal of them, and putting them right here to evaluate them out. So let's go ahead and take a look. The reciprocal of 0 is going to go ahead and be 1 over 0. Well, and division by 0, as we learned with tangent, is going to give us undefined. Okay. This guy right here, we take the reciprocal of 1 over 2, and we get 2 over 1, which is just 2. This guy is going to require a little bit more work, as we take the reciprocal of square root of 2 divided by 2, and that's going to give us 2 divided by the square root of 2. We need to rationalize the denominator by multiplying the top and the bottom by the square root of 2, and we get 2 square root of 2 all over 2, which those cancel out, and we get the square root of 2. This guy right here, we take the reciprocal of square root of 3 divided by 2, and we get 2 divided by the square root of 3. Multiply the top and the bottom by the square root of 3, and we're going to get 2 times the square root of 3 all over square root of 3 times square root of 3 is 3. And then finally, we got 1. The reciprocal of 1 is 1 over 1, which is this 1. Okay? And really, that's the way that you do each one of these. So you're taking the reciprocal of sine and putting it right here. Reciprocal of cosine, and you're putting it right here. And the reciprocal of tangent and putting it right here. Okay, so I'll let you go ahead and do those columns, and here is the result that you want to check your work against. Okay, so there it is, and in the next part, I'm going to go ahead and make a larger version of this entire chart right here so we can see it better. And we're going to take a look at noticing some of the patterns and whatnot in regards to the unit circle here, and then move on over into some shortcuts to evaluating these, because sadly enough, we have to go ahead and be responsible for this entire chart and understanding it. Okay, without a note card eventually. So I'm going to get going in that direction. So yeah, I will see you in that next video. All right, in this video, we're going to go ahead and take a look at this business of what the quadrants are going to mean in regards to the actual sign, and when I say sign, a positive or negative for all of the trigonometric ratios that we found right here. So first things first is that one thing that we should remember is that over in the first quadrant, which is going to be right here, okay, is that we're going to have, if we look in the first quadrant, all of these guys right here, okay, so that's in the first quadrant. Boy, is that thing going slow. Oh, boy. Are going to be positive. So what we're going to do is that we're going to say that all of the trigonometric ratios whose terminal side ends in the, or lands in the first quadrant are going to be positive. So all of them will be, all right? In the next quadrant, we're looking at, okay, well, let's take a look. We have, in the second quadrant, it appears that only sine, okay, so I go over here, and its reciprocal are going to be positive, and if you look, the rest are negative. So only sine is going to be positive, and the reciprocal of it, which is going to be the cosecant. Okay? In the next, the third quadrant, which is right here, if we look, the only trigonometric ratios that are positive are going to be tangent and cotangent. So we got tangent and then cotangent. And then finally, we're going to take a look at the fourth quadrant right here, and that is going to have just cosine, okay, and secant being positive. So in this, with this in mind, is that we're going to go ahead and carry over this concept into kind of like a shortcut to go ahead, and so we don't have to memorize all these values and whatnot out, or this entire table. We're going to go ahead and use the fact that all right here are going to be positive in the first quadrant, sine in its reciprocal function in the second, tangent in its reciprocal function in the third, and cosine in its reciprocal function in the fourth. Okay, so let's go ahead and go to the next video so we can see how this is going to play out. Okay, so in this video, we're going to go ahead and take a look at a way that we can just have to memorize a certain amount of information from this very exhaustive trigonometric chart that we made here, and use reference angles and all of the quadrants' positive values that we learned in the previous video to go ahead and evaluate trigonometric ratios. Okay, so let's go ahead and take a look at the part that we are going to grab from the exhaustive list of functions on the side here. Okay, so using this method, we can go ahead and just basically memorize this part that's in that yellow rectangle there, and put it over here, so, and use small sketches of the unit circle to go ahead and start to put these pieces together. So let me go ahead and fill in the rectangle to the left here. Okay, so here is this chart here, and what we're going to do is that we're going to do the first example, and I'm going to fill them in as we go, and I'm going to do as many examples, let's do 8 of them so we can see how this works. Alright, so here we go. And notice that I have removed the chart because we don't want to lean on that thing the entire time that we're doing these. We want to use this method because, again, this method is going to help us streamline what we've learned. Okay? So if I look at the sine of 120 degrees, we know that our reference angle is going to go ahead and, our angle is going to look like this. So here's our 120 degrees. Now, if that's 120, we know that our reference angle is going to be what's left over to make 180, so this is going to be 60 degrees. So we're going to have a 60 degree reference angle. So we rewrite this as the sine of 60 degrees. Now, to do the last part, okay, is that we're going to take a look at where the terminal side has, and that's this guy right here, has landed. Notice that it's landed in sine's quadrant. So that means is that the result is going to be positive. Then I just need to look up top and find the sine of 60 degrees, which is going to go ahead and be root 3 over 2. So I know that that is going to be the square root of 3 over 2. Okay, let's take a look at another one. Okay, in this one we have the cosine of 135 degrees. So that means is that it is going to go ahead and be right here, and that guy is going to be the 135 degrees, and the reference angle that is going to complete the 180 is going to be 45. Okay, so we rewrite this as the cosine of 45 degrees, and we notice that the reference angle, or I should say the terminal side right here, has stopped in Sineville. Now, that basically means is that cosine is going to be negative there because only sine and its reciprocal are going to be positive. So therefore, that's going to give us a negative square root of 2 over 2, because the cosine in the reference angle is going to be the 45 degrees right here. So you can see that a reference angle is handy because it's always going to go ahead and put things back into this chart here, and we don't have to memorize that entire giant chart that was off to the side over here. Okay, let's do another one. Okay, in this example, we're going to take a look at tangent, and we also introduce some radians here. With radians, I just want to go ahead and make sure that we need to go ahead and find where the angle is going to, the terminal angle is going to land. And so I want to make sure that we, again, go back to the way that we found the radians before, going, all right, well, if this is going to be a 4 right here in the denominator, we know that we want to count around the circle, go in 0 pi over 4, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. And so we know that it's going to land right here, okay? So we don't want to lose track of how we got those to begin with. So if I were to look at each one of these increments are going to be pi over 4s, right? And I found out that this angle is all the way over here. So it looks like that one chunk is going to be the reference angle right here of pi over 4, okay? And so therefore, looking at the bottom part here, we got the reference angle right here of pi over 4. So, and let me draw the original in here. Okay. And so what we want to do then is that we have then, we're rewriting it as the tangent of pi over 4. Okay. And the tangent of pi over 4, we know from the chart right here, the tangent, same thing as 45 degrees, is going to give us 1. But we know it's going to be negative because it landed in the cosine part. So when it does that, we know that we have to put a negative here because it is not, tangent is not cosine or the reciprocal of it. It's tangent. Okay, so it's going to be negative. So that's how you'll do those guys. And I want to take a look at a negative angle as well in this next example. Okay, so it looks like we're going to tackle the tangent of a negative 120 degrees. So if we're going negative, remember is that we have to go in this direction here. And remember that that little guy right there, that's 90 degrees right here. So 30 degrees past that is going to give us that 120 degrees, where the reference angle is going to be 60 degrees right here. So the reference angle is going to be 60, and we want to rewrite that as the tangent of 60 degrees. So that said is that we look, and we know it's going to be positive because it's in the right quadrant. That's good. And we know that the tangent of 60 degrees is going over here to the table, and the square root of 3. And so therefore, the tangent of a negative 120 degrees is the square root of 3. Okay, in this video, we're going to go ahead and take a look at the reciprocal functions, or at least some reciprocal functions, to get an idea of how to do these out. Okay, so let's take a look at the cosecant of, let's go 210 degrees. Okay, so if we're looking at 210 degrees, we know that that is going to be roaming all the way over here. And there we go. Okay, and so for our reference angle is going to go ahead and be this guy right here. Okay, so the reference angle is going to be 30 degrees. So we rewrite this as the cosecant of 30 degrees. So now what we got to go ahead and do is that we think about, okay, well, cosecant is the reciprocal function of sine, okay? And we know that the sine of 30 degrees is going to be 1/2. So what we're going to do is that, and I'm just going to write this off to the side because I don't want to smash the room here. So I got this guy, And I know that the sine of 30 degrees is 1/2, and so the reciprocal is going to be 2. We also got to keep in mind that this is in tangent territory, so that means is that it has to go ahead and be negative, because only tangent and cotangent are going to be positive in the third quadrant. So we say that that is going to be a -2. Okay, let's look at another one that has to do with radians. Okay, so here we got the cotangent of a -π/6. So a -π/6 is going to be going in this direction here, okay? And remember that π/6 is equivalent to 30 degrees. So it looks like that we are going to go ahead and have, this is going to be the actual reference angle, π/6, okay? So we can just rewrite this as the cotangent of π/6. All right, so loading things up on the right-hand side here, we have the tangent of π/6. We want to figure that out first because that is, and take the reciprocal of it because that's going to give us what cotangent is. And so I have tangent of π/6 is going to give me √3/3. So when I take the reciprocal of that, that is going to give me 3 divided by the square root of 3. And then I multiply the top and the bottom by the square root of 3, and that is going to give me 3 square root of 3/3, and now the 3's cancel out. And so at the end of the day, I have the square root of 3 for cotangent. Now, notice that it is in, to finish up the answer, because we have to go ahead and put a plus or minus sign, it is in cosineville, and that means is that cosine and secant are the only positive trigonometric ratios in the fourth quadrant there, and so we're going to get a negative square root of 3, okay? So, let's take a look at some of the angles that fall on the x and y axis. So let me cue those up real quick. Okay, so if I were to go ahead and have the cosine of a -90, this means is that I'm going to have this fall on the y-axis here, the negative y-axis, and so it doesn't make a reference angle that's going to have to make a triangle like we saw before. So what I want to do is that I want to, I'm going to sketch a circle off to the side real quick. Okay, and so this is where we have to remember all the definitions of the sine, cosine, and tangent as we go ahead and relate to the x's and y's of all those parentheses. And so when we're looking at this, we have these coordinates that are going to match things up, okay? And so if I were to look at cosine, which from this picture down below, I'm going to put it up here so we can see it a little bit better, is that we notice that the cosine then of 90 or negative 90 degrees is going to put us on the y-axis, and that's going to be the x value. And so we can basically skip right to the chase with that and just say that the solution is going to be 0, okay? And likewise, if I have the secant, which is going to be the reciprocal of cosine, I would go like this on over here. And I notice that if I wanted secant of a angle, that's going to be 1/x, okay? So I go ahead and I go 1 divided by a -1, which is just going to give me a -1 here, okay? Because the x value that it's pointing to is going to be a -1. So anytime that they go right to an x or y axis, and the terminal side of the angle falls on it, then you know that you can just go ahead and use the x and y value, and that's the easiest way to knock those things out. Okay, so I'm going to include some more examples of this on the website as well, and I'm including a assignment that looks like there's quite a bit to do with it, lots of practice with this stuff, and so it might be a little bit difficult at first, but hang in there, and I promise you'll get the hang of it. So I will see you then.